be able to do by the end of this lesson is that I can graph numbers on a number line and find absolute value. So, right here, I can graph numbers on a number line and find absolute value. So, to get us started, we're going to look at some vocabulary. The very first one is real numbers. And real numbers are any and all numbers found on a number line. Okay? So real numbers are any and all numbers found on a number line. That's all the numbers in between the gaps and in between your notches. That's everything you could possibly graph on a number line is a real number. And real numbers have 5 subsets. Okay, so the 5 subsets are just groups within that big group. So the smallest group within real numbers is our natural numbers, and we call those our counting numbers. So think back when you're little and you're learning how to count. That's the numbers that come natural to you, like 1, 2, 3. Those are your natural numbers. So 1, 2, 3, dot, dot, dot for as high as you can count. Now after natural numbers are our whole numbers. And whole numbers are our counting numbers and 0. So how the first group started with 1, 2, 3, the second group is going to start with 0, 1, 2, 3, dot, dot, dot. So it's natural numbers plus 0. And now our integers are next. And integers are whole numbers and their opposites. Integers are whole numbers and their opposites, which means we're going to have negatives now. So positive and negative numbers. So if I go on like I have been doing, I will start with the negative number, so it'll be dot, 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 negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, dot, dot. Because if you think about it, the opposite of positive 2 would be negative 2. So whole numbers and their opposites. Our next group is rational numbers, and it says terminating, which means it ends. So terminating or repeating decimals, and it's any number that can be written as a fraction. So if you think about a terminating decimal, that's like 0.5 because it stops. That's as far as it goes. And it says any number that can be written as a fraction. Well, I can write 0.5 as 1/2. Same way for a repeating decimal. If I write 0.3 repeating, well, that's the same thing as 1/3. And I can grab a whole number like 2 and say 2 over 1, so I can write a whole number as a fraction. Same way I can write an integer. I can take negative 3 and write it over 1. So rational numbers are anything that can be written as a fraction. That's the big one. And then our last subset is irrational numbers, and it's never ending and non-repeating decimals. And I always like to kind of mention that that means if you were to put an irrational number in your calculator, the decimal would never stop. So it would never stop. And when it says non-repeating, that means there's no pattern to find. Like a number might repeat once or twice, but there won't be a pattern to it. So never stops and no pattern. And numbers we like to use for irrational are pi, because pi is 3.14, and it's a real big decimal that keeps on going and going. We just recognize 3.14. or like the square root of 2, because if you were to put that in your calculator, it would be a decimal that would be 1 point, and then it would keep going on, and it would never repeat, and it would not have a pattern. It would go all the way off your calculator screen. So that's an irrational. As I always consider this like the Russian doll, because if you've ever seen the Russian dolls, like those are like the little doll in the middle, and the bigger doll on the outside, and a bigger doll, and then a bigger doll. It's like when you open it up, the dolls keep getting smaller. But we're going to do that for our real number subset. So if you'll draw out this table in your notes, there's one really big rectangle here. And then inside the big rectangle, there's a smaller one in which this left side gets, the right side gets cut off, and the left side gets 3 more smaller boxes in it. So I'm going to give you a second to copy this into your notes. And this is going to be our real number subsets. Okay. I always like to start out with our smallest one and work our way out. So the one in the middle, this is our natural, because we said it's our smallest ones, our counting numbers. And now we're going to use a letter. So natural numbers we actually denote with the letter N. Okay? And we already said those were our 1, 2, 3 for as high as we could ever count to positive infinity. Alright, to the next group is whole numbers. So whole numbers is denoted by the letter W. And it is the natural numbers in 0. So it starts out 0, 1, 2, 3, ... So if you notice, it's the Russian doll in the 1, 2, 3 in the natural numbers, and it's also in the whole numbers 1, 2, 3. The only thing whole numbers does is add in 0. Then integers is just bigger than whole numbers. So integers, and it gets denoted by the letter Z. And we say it's whole numbers and they're opposite. So if I look at my whole numbers, 0, 1, 2, 3, ... And then say the opposite of positive 1 is negative 1. Opposite of positive 2 is negative 2. Opposite of positive 3 is negative 3. And it could go in the other direction. So we have dots on both ends to show it's all the negatives and all the positives. So once again, our natural numbers are also whole and integers. They're in all these groups. Same way whole is also in integers. Now the group just beyond integers is rational. Remember, we said rational is anything that can be written as a terminating decimal, repeating decimal, or fraction. And rational gets denoted by the letter Q. And we said it was like if we have 0.5, and we said it's 1/2. 0.3 repeating is 1/3. We can even throw in a natural number of 2 and put it over 1. So natural numbers in all these groups now. So that's why it's kind of like a Russian doll. It keeps getting bigger and bigger and bigger. Now the one off to the side, he's all lonely because he's our irrational. Irrational stands off by itself. So the irrational gets denoted by the letter I. And we already said that's like pi, square root of 2, square root of 5. And our biggest group, and the one that encompasses all the subsets, are our real numbers, and it gets denoted by the letter R. So all these numbers in here get denoted by the letter R. Example 3 gives us 5/22. Okay? And wants us to name the set the number belongs to. So we're going to put Q for rational over here. And all the numbers we look at today and for the whole year are going to be real. So Q and R. Now, example 2, we're given the square root of 121. The very first thing we need to see is, can it reduce? Can I take the square root of 121? Yes, I can, and it gives us 11. Now, 11 is a number I can count to, and because I can count to 11, it makes it natural, which is also whole, an integer, rational, and real. So the smaller the group it's in all of them. So it's in all of these, natural, integer, rational, real. So if it's in the smallest one, it's going to be in all of those. Now our next one, our example 3, gives us the square root of 56. And once again, we need to see, can I take the square root of 56? So let's do that real fast. Square root of 56 gives us 7.83, or sorry, 0.74833, and it keeps on going, and it doesn't have a pattern, it doesn't repeat, and it doesn't end. So that makes it irrational. And all of our numbers, once again, are real. And our fourth and final example for this set, oh, I got off numbers, so that's 3, 4, 5, this is example 6, that was my mistake, I'm sorry. So example 6 has -36/4. So because our top number is bigger than our smaller one, we need to see if we can simplify that. So remember that fraction bar tells us to divide. So -36 divided by 4 is a -9. And then once again, go back to your number subsets. Would I count -9 for my niece who's 4? Is it a natural number I would count for a little kid? No, so it's not natural. Whole is all your counting number in 0, so it's not 0, so it's not whole. Integers are all your whole numbers and their opposites. So 9's a whole number, and the opposite of +9 is -9. So it's an integer, which is z. It's rational and real. Our very first vocabulary word is square root, and it says 2 of the same factors of a number. So the same means it has to be the same number and itself. So a number and itself. Remember back in our first lesson ever, factors? It's the two numbers that multiply together. So two numbers that multiply together to make it. So, for example, I have the square root of 4. Well, 4 is made up of 2 and 2, so square root of 4 is 2. Okay, our next one is perfect square. And perfect squares is when a square root equals a rational number. So I'm just going to refer you back up here. 2 is a rational number, so square root of 4 is 2, is also a perfect square. It's when a square root equals a rational number. Our last one is rational approximation, and it is to approximate an irrational number to a close rational number. And basically, the big keyword here is the approximate, and that just tells us to estimate, so estimating numbers. Okay. Now, our examples. Example 1, remember to write what I have here in my marker, so example 1. And we're given a negative square root of 49 over 256. So, even though we see this negative symbol out here, we're just going to drop it down. So drop down our negative symbol, and our square root bar is over a fraction. So I break it apart and put it over just the numerator and just the denominator. So 256. If you want to make yourself a little note to We're just going to take the square root of each number. Square root is something you all can see either on a multiplication table or on your calculator. There's a couple of different ways you can find your square roots if you're not used to doing them on your own. Most calculators will have a x squared button. There we go. Like that one. And then, I know it's really hard to see, but right above it, there's a little square root bar. So if your calculator square root bar, you can use it. If it doesn't, you can use a multiplication table or whatever else you have. But a number in itself that makes 49 is 7. So I drop down my negative symbol again and say 7 over. And then once again, we need a number that can go in 256. And that is 16. And itself can go into 256 evenly. The number 1 is a negative 7 over 16. Our second example, we have a plus or a minus square root of 0.81. So once again, we're just going to drop down our sign, plus or minus. And what that means is that the answer could be positive or negative. And then square root of 0.81 is 0.9. Because if you see, if I ignore this first part and just say, what's the square root of 81? 9, and then just put my 0 and my decimal, that's another way to do it. So there's our example. Once again, when you get in decimal form, example 11 gives us 2.63 repeating, negative square root of 7, 8 over 3, and 53 over negative 20. 53 over negative 20. And once again, we're dealing with different types of numbers. Let's get them all as decimal. The very first one's already in decimal form, 2.63 repeating. Our next one's a negative square root of 7. So once again, we drop down our negative symbol. And we say that's 2.646 because it rounds up. Our next one's 8 divided by 3. So we'll go ahead and do that one. We get 2.6 repeating. And the very last one, we get 53 divided by negative 20. And that gives us negative 2.65. We're asked to arrange these in order from least to greatest. So we have to find our smallest number. I'm going to go ahead and warn you, you can't be deceived by the negative symbols, okay? So remember, I'm going to sketch out here, if you have your number line, the farther to the left it is, the less of a number. So the farther left it would be, the lesser it is. So from least to greatest. So which one of these would be my least? So if I look right here, my negative 2.646 and negative 2.65, this one would just be a little bit farther left because it's just a little bit smaller. Because it's a bigger negative means it's farther left, which means it's going to be my smallest. So this is number 1. It's my smallest one. And what I'm going to do is I'm going to write the original. So I'm going to write down 53 over negative 20. Then my only other one I have is my negative square root of 7. So once again, we're going to write in the original, which was negative square root of 7. All right, then I have 2.63 repeating and 2.6, which means the number after this one's another 6. So which one of these would be my smaller number to put next? And it would be my 2.63 repeating. And my greatest one and my original here and it is my biggest number. So once again, just go through, double check yourself. That's 1. This is the second smallest, or third, which makes, use my largest number. Alright, and that gets us through this set of notes. 2.7's finished, so be prepared for